Well, hello there. This is Dr. Dell, and this video is for one of our students. I'll call him Ethan. And he asked me a question recently that came up like this. We had a circle, and we had a triangle, and this was the tangent. I'm not a very good artist here. Freehand. And this was an angle, and I'm going to call this angle X for now. And this was a length here. And the question is, what was the area of the circle? Now, we were given X and we were given L. In fact, in this particular problem, we were given L was 12 and X was 45 degrees. Now, the area, if we call this the radius, we all know that the area is pi times the radius squared, okay? So to answer the question, we really did need to figure out what R was. Now, like I said, in the very first problem that he gave me, the angle X was 45 degrees. This was the problem we had to solve. Now, we can use geometry to do this. If X is 45 degrees, then what is this angle up here? Well, that'd be 45 degrees also, because the sum of the angles of a triangle is 180. And if you have a tangent line, this is always 90 degrees. So what that means is that these two sides are equal. This side here is equal to this side. And so we can use the Pythagorean theorem, and we can say that R squared plus R squared is equal to L squared. Pardon my writing. So R squared is 1/2 of L squared. And we want to know R squared, so the area then is simply area is pi times 1/2 times L squared. Now in this particular problem, L was 12, so L squared, you can do that with your calculator. It's 144. You take half of that, that's 72. And so you had pi times 72. And now we have our trusty calculator. I always use the TI-30XA. And 72 times pi, and that's on the calculator, is 226 to the nearest whole number. So the answer was 226. Now I want to elaborate on this. Suppose that I had told you that angle X was 60 degrees. Well, then that means the other angle, the complementary angle up here, was 30, and that would have told you, if you study geometry, if you have a right triangle, the side opposite 30-degree angle is 1/2 the hypotenuse. So R in this case would be 1/2 L, and so R squared would be 1/4 L squared, and the area then would be pi times 1/4 times L squared. So whatever L was, you could plug it in here and get the answer. What if angle X had been 30 degrees? Well, now you use the Pythagorean theorem again, and you would be able, with the Pythagorean theorem, to demonstrate to yourself that R squared is 3/4 L squared. Use the Pythagorean theorem to get that. Because if this is 30 degrees, if X is 30 degrees, then this opposite is 1/2 of L, and then if you use Pythagorean theorem, you would get this to square root of 3/2L, and you square it and you get that. So pi would be, in this example then, or the area rather, would be pi times 3/4 L squared. Now, as I told you in my Uncle Jack videos, and if you're on the family plan for our training, my Uncle Jack would have been able to figure these out because he understood how to deal with triangles where you had a right triangle where you had 35 or 45 or 60. And I explained that in the Uncle Jack videos. And in fact, he always said when you're building things, these are the only useful angles, because this is what he knew. He knew the numbers based on geometry. He didn't even know the Pythagorean theorem. He just knew these numbers here. He knew that if this was, if x was 30 degrees, he knew the opposite would be half of that, and so forth. Now I want to show you how this problem can be solved using trigonometry. Now, if you're studying my math and you're studying Tier 2, first you learn some algebra, and then you learn the Pythagorean theorem and geometry, and the things we've done so far. You can do this with geometry. But what if you had trigonometry available? Now, it used to be trigonometry was considered an advanced subject, but today, thanks to the calculator, it's really pretty easy, and we cover that basic trigonometry for this sort of problem in the last 7 lessons of Tier 2. So let me show you how you would do this in general. You would learn that R divided by L is what is called the cosine of the angle X. You would learn that. Well, that means that R then would be L times the cosine of angle X. And that means that the area then would be pi times what? L times cosine of angle X squared. And that would be the formula. And then you could plug it in. So let's plug it in Ethan's problem. L is 12, and so you get 12. Now what's the cosine? In this case, X is 45 degrees, so you would take your calculator and clear it, and hit 45 and hit the cosine button. And then you would multiply that times 12. And then you would square that. And guess what? You get 72, and that's what we had before. And then multiply that times pi, and you would get 226. So this would be the most general formula. Now, why am I telling you this? Well, when you learn math, it's like climbing a ladder. The first thing you learn is some basic algebra. Actually, the first thing you need to learn is how to use a calculator, which we teach that, of course, in Tier 1. Then you learn some basic algebra. Then you learn some basic geometry, and then basic trigonometry. Now, this is the math that's always stood me in good stead doing practical problems all my life. As you know, I'm making this video shortly after I had my 81st birthday, about 3 weeks ago. And I learned the math I'm teaching you now when I was in high school. And that was, of course, long before calculators came out. And these problems were pretty hard to do then because you'd have to look up the cosine in a trig table. Then you'd have to do all these calculations with pencil and paper, and it was pretty time consuming. In 1972, the scientific calculator, first one, came out, and life became much, much easier. Once you had the calculator, you could do the calculations so much quicker. Well, by the late 1970s, one of the things I was doing was developing a thing called the Dynabrain, and it was a computer system for monitoring racing engines on water brake dynamometers. And I had a lot of customers that were in the racing business, drag racing, 500-mile type racing, but my biggest customers were NASCAR. And so I was always dealing with engine builders in NASCAR. And they were always asking me math problems. And this would be, something could be like this. And I would solve the problems for them using exactly the things you're learning now in Tier 2. And I had a calculator. This was in the late 1970s. In fact, my largest client at that time was a racing team called Australian Racing. Roland Wolodka was the general manager, and he was always asking me questions to solve for him, math problems, which I would do. And by the way, their racer at that time was a racer I'm sure you've all heard of. His name was Dale Earnhardt. I met Dale when he first went to work for Australian Racing before he was famous, and then, of course, he became quite famous after that. But I knew most of the racers at the time. I knew Richard Petty, and I knew Cale Yarborough, and I knew Darrell Waltrip and Buddy Baker, all because I was dealing with their engine builders, and they'd come around the shop, and I'd meet them, and I didn't know them well. I would meet them and say hi. We'd chat a little bit about different things. But the engine builders all thought I was a genius because I could solve practical problems. Well, that's what you're learning to do. In Tiers 1 and 2, you're basically learning practical problems. And this would be the kind of problem that I might solve for them, something like this. And because I knew the basic geometry and trigonometry and algebra, I could solve all kinds of problems. And this is just an example of it. So you shouldn't be doing this, I don't think, just because you want to pass a test. I think you want to be doing this because it's going to open up things for you to do. I built a drag strip called Action Dragway, best 8th mile drag strip in the world at that time in Terre Haute, Indiana, which is where I lived. I was teaching in Terre Haute at an engineering school called Rose-Hulman Institute, and then I built the drag strip. And I did a lot of other things, and practical math has always stood me in good stead. I went to the military one time and took some tests, and I scored very, very high. Why? Just because of things like I'm telling you here. So I want you to, as you go through our training now the first 2 tiers are basically what I would call workforce math. It's what I would use for practical math. Then in tier 3, I get into a lot of math that you would use in business and just in your regular life. All sorts of things that will help you with your financials and with analyzing things in business and that sort of thing, and probabilities. And then that in tier 3, I'm also getting you ready for the SAT test, but there's really a lot of practical math there that'll be very valuable to you that I've used throughout my life. Now, if you're interested in science and engineering, then you're going to have to go way beyond what we've done, and you're going to have to go into tier 4. And in tier 4 now, you're going to learn algebra and geometry and trigonometry at what I'd say is a much deeper level. But fortunately, it's very easy today because of the new tool, Wolfram Alpha. And so tier 4 today used to be, when you went into those subjects without a tool like Wolfram Alpha, they were quite challenging. They're much easier today. In tier 5, we do calculus. Calculus is absolutely necessary to analyze what are called functions. And functions are what are used in all math models in science and engineering. And then tier 6 is differential equations, and that's what you use to find the functions. You set up a differential equation that models whatever you're doing. The solution is a function. You analyze the function using calculus, and so on. Now, these used to be very difficult subjects, and you didn't usually study them until you got into a university level. Well, today you can learn them in high school. And why is that? Why can you learn calculus and differential equations, Diffie-Q they call it, in high school? Because of Wolfram Alpha. And so if you are today a high school student and you're interested, you think maybe in science and engineering you're going to want to go through tiers 5 and 6, and I would find today, I will tell you this, I've had a lot of students over the years, and I've had a lot of students that are actually more gifted than I am in mathematics. I'm not all that gifted, and most students are able to learn math the way I did. I was lucky I had some good teachers, and I hope that I can be your teacher. There's very few people that can't learn math if they take the time to do it and climb the ladder one step at a time. So I wanted to tell you this as a follow-up to Ethan's question about this particular problem. I wanted to expand on what you can do. First with geometry, with these angles right here, you can handle those with geometry. You don't need trig. But then in general, you get into trig, and trig is actually very easy to use. In fact, the ultimate thing you're going to learn in trigonometry in tier 2 is you're going to be able to take a triangle with arbitrary 3 sides. And you'll be given this side, side 1, side 2, and side 3. Not a right triangle, just an arbitrary triangle. And what's the area? And that's the last thing you're going to learn in tier 3. And with trigonometry, you can do this problem in about a minute with the calculator. It's not hard to do. It's very difficult to do if you don't understand what's called the law of cosines, or the generalized Pythagorean theorem. And that's the last thing I teach you in tier 2. And then once you learn to do that, you'll be able to do problems that you're going to be able to do a lot of problems that most people find confusing if they haven't studied math. And by the way, back in the older days, this was very difficult to learn because you didn't have the modern tool. The calculator makes everything much easier. And then, of course, as I said, when you get into the higher level math that you're going to need for science and engineering, tiers 4, 5, and 6, you're going to start using this wonderful tool, Wolfram Alpha. And by the way, that tool came out in 2009. So this was not available back when I was a student. That's what makes math so much easier today, and you're going to really enjoy it and have a lot of fun doing it. And then the math is a tool that you're going to use then. If you want to study engineering or science and that sort of thing, then math is the tool you need. Then you can study physics and chemistry and electrical engineering and mechanical engineering and all those things. So this is Dr. Dale. I hope you enjoyed this video, and perhaps you will be inspired now to continue learning math. It's really quite easy today. It can be a lot of fun. It's extremely useful, and it'll open up all sorts of doors of opportunity for you. So Dr. Dale, hopefully I'll see you on a bunch of math training videos. Hope you're having a great life. Bye-bye.